This force, we are going to call it as weight. Reaction. Reaction, we are going to use the symbol of big R. Reaction. And remember, this reaction is always 90 degrees to the surface. 90 degrees to the surface. 90 degrees. Must be always 90 degrees to the surface. Huh? That's why if you don't want to call it as reaction, so some book you will find it as, they use it as the word of normal. Normal. Normal, then we use the symbol of N. Newton's third law said, the action here refer to the weight. This is the action. The weight, it is our action. The action will pull it down. So every action, there is a reaction with the same magnitude. If this one 10 Newton, then this one 10 Newton. So it is not moving. If this one 20 Newton, the weight 20 Newton, so this one going to be 20 Newton, so that it is not moving. It will be the same. Right? So the R here will be equal to the weight. If this is a car, right? So this is a forward force. This forward force, we normally call it forward thrust. I name it as F. So because of force, too many force, I put it as T, all right? Forward thrust. Now that is one force acting backward. Newton said, when you got forward force, you got an action, they must have a something backward reaction with same magnitude, right? If this one is not moving or moving with constant velocity, so this force, it is called frictional force. Now, normally it is using FR, frictional force. Frictional force. But me, myself, I like to use this frictional force. I'll use this symbol, mu. So we can say the forward thrust is equals to the mu. The forward force is equals to the backward force. This one and this one, it is the same. And the force that upward and downward will be the same. R is equals to W. We call it as equilibrium. Now, remember, the equilibrium, you must have the object, it is not moving. Object not moving, or if it is moved, must move with constant velocity. And when it is equilibrium, right? So we can call it as net force is equal to 0. Or you can call it as resultant force is equal to 0. Resultant force is equal to 0. The acceleration is equal to 0. Do you know it? That is one force pulling upward. This force, it is called tension of the rod. Normally, I call it as tension will be okay. Remember, the tension is going upwards. Newton said for every action is a weight, there is a reaction. Same magnitude, but opposite direction. This object is not moving at rest right now. It is at rest. So I will say this one is equilibrium because it is not moving. So I will say T is equals to W. And there is nothing to hold it, no tension, no reaction, no nothing, but this one's still going same height. So now must be something supported. So we call it as engine upthrust. Or you can put this as T, you can put this as F. This is called engine thrust or forward thrust. Engine thrust. That is one force. Make the thing aeroplane hard to move forward. So that one is called frictional force. But this one is because of it is air friction. So we call this air friction. We call it as, I said I will use the symbol of mu. But if you don't want to use air friction, that is another name, right? That you can use, we call it as drag. G. Then the forward force, the forward thrust is equals to the backward force. T is equals to G or T is equals to mu. It is okay. The W and the F will be the same. F is equals to the W. F is equals to the W. So these two will be the same. When you see the word of constant velocity at a constant height, right? Forward thrust. This one is called friction. You see, this thing is accelerate. So this thing, it is not moving with constant velocity, it is accelerating. This one is not equilibrium already. When you see the word of acceleration, mean it is not equilibrium. Mean forward force, Ft. Forward force is more than the W. This one minus this one, you got a net force. R is equal to the W. Why? Because this thing, this trolley, it is not going to accelerate upward. It is accelerating forward. So up and down still the same. So this one you got one resultant force, right? This one is not equilibrium, right? But what is not equilibrium, right? Not equilibrium mean acceleration, it is not zero. It is accelerating, meaning that the net force or the resultant force, it is not equal to zero. You will see this one, you need to use F is equals to MA to calculate in the future. Forward, you accelerating forward. It is not constant velocity. When it is not constant velocity, T is greater than G. Because of you said it is upward, this one is going upward, this one is heavier, this one is bigger. So F is greater than W. Oh my, I want to find the acceleration. What's 10 minus 2, which is at MA, M. M. Hey, this one should be 500 gram. I'm sorry. Yeah. 500 Newton, no, 500 gram. I want to go to the same question, right? 0.5 A. So A is equals to 0.5 A. So give me the A. Give me the A. Right? So you get it as 16. Now, see,